Hello, Algebra 2 Trig. This is Mr. Walker, and we are going to start Unit 13 today. Alright, so in Unit 13 we're going to be looking at simplifying trig expressions and also solving, and I think we're doing graphing also. So let's go ahead and get started. Reciprocal functions, you want to start to memorize which ones go with which, so then you can use them to simplify faster. You can refer back to these notes as we progress into 13.2 and 13.4 also. All right, or 13.3. So reciprocal identities. The sign is the reciprocal of the cosecant, and so we can go ahead and write that. The sign is 1 over the cosecant. And then the cosecant is the reciprocal of that, so it'd be 1 over sine. All right. Cosine is the reciprocal of the secant, all right, and secant is the reciprocal of the cosine. So cosine is the same as 1 over secant, and then secant is 1 over cosine. And then tangent and cotangents are reciprocals of each other. So tangent is the same as 1 over cotangent, and then cotangent is the same as 1 over the tangent. All right, so remember, when you see 1 over something, that means it's the reciprocal. All right, so if the number is 5, then its reciprocal is 1 over 5, x, 1 over x. All right, then we have these quotient identities. So they work for tangent and cotangent. All right, so if you remember tangent, that's the same as the y value divided by the x value. All right, when we're looking at the unit circle, y over x. All right, and from the unit circle, we also know that the y value was the sine, and the x value was the cosine. So tangent is also sine divided by cosine. So it has two different identities, tangent. Tangent, you could use 1 over cotangent, but you could also use sine over cosine. And then cotangent works the same way. Cotangent was x over y, and then we could replace those with cosine over sine. All right, so it depends on what you need, which version you need to help you simplify the more complex trig functions. That's the one you're going to use. All right, and then we have this what's called the Pythagorean Identities. So Pythagorean Identities comes from the Pythagorean theorem. All right, so if you remember, a squared plus b squared equals c squared. All right, so I'll just write it right here. A squared plus b squared equals c squared. Well, in our triangle on this unit circle, the horizontal part was x, and the vertical part is y. And so we could replace those with, those are the legs of the right triangle, and the hypotenuse we can see is 1. All right, so then we have x squared plus y squared equals 1 squared. But then we could replace the x's and the y's with their trig functions. So x is the same as cosine. And y was the same as sine, and then 1 squared is 1. So we get this new identity, okay, using trig functions. So cosine squared plus sine squared is equal to 1. All right, so then we could use that Pythagorean identity, and we could come up with 8 more versions of that. All right, so there's lots of versions from that. So we're going to see how this works. All right, so I'll put this first one right here in this box. Cosine squared plus sine squared equals 1. All right. So I could take that and I could solve for cosine squared and get another version of that. So I could subtract sine squared over. If I subtract sine squared over, I'm going to get 1 minus sine squared, and that's equal to cosine squared. I could take this main one and I could solve for sine squared, so that means I would subtract cosine squared over. All right, so that'd be 1 minus cosine squared. All right, so 1 minus cosine squared is sine squared, and 1 minus sine squared is cosine squared. And those are all coming from this main Pythagorean identity. All right, so then I could come up with some other versions of this. All right, so let's say I take this sine or cosine squared plus sine squared Put the plus in there. And let's say I take that and I divide everything by sine squared. All right, so as long as I divide by the exact same thing to every single term, then it's legal. All right, so now I simplify that. Well, if I simplify cosine squared divided by sine squared, well, that's a reciprocal identity, and that's cotangent squared. All right, so I'll just write it right here. Cotangent squared plus, and then sine squared divided by sine squared is 1 equals, and then 1 divided by sine squared, well, it's the same as 1 over sine, and that's cosecant squared. All right, so I get this new identity here. Well, then I could take that and do the same thing that I did before, and I could get cotangent squared by itself. All right, so if I get cotangent squared by itself, I would subtract the 1 over. So I get cosecant squared minus 1. Well, then I could take the original one, cotangent squared plus 1 equals cosecant squared, and I could get 1 by itself. I could subtract cotangent squared over. All right, and so I get this other version of it. All right, so then I could go back to this original one, this cosine squared plus sine squared equals 1. And instead of dividing by sine squared, I could divide everything by cosine squared. All right, so let's say I divide everything by cosine squared. So if I simplify that, I'm going to get 1 plus, well, sine squared divided by cosine squared is tangent squared, and 1 divided by cosine squared is secant squared. All right, and then I could take that and do the same thing that I did before. I can get each of these expressions, these terms by themselves. So I could get 1 by itself. All right, well, I get 1 by itself, I would subtract tangent squared over. All right, now what I could do is get tangent squared by itself. And to do that, I would subtract 1 over. All right, so you can see here's 9 versions just coming from that main one, cosine squared plus sine squared equals 1. All right, so let's keep going, and we're going to kind of use those, and we'll keep referring back to those identities. All right, so now it says simplify each trig identity. All right, so we have cosine x times secant x. So we're trying to simplify this. So one main process to use is to change things to sines and cosines. Right, so change to sines and cosines. All right, so if we can get that, then a lot of things start to cancel out. All right, so this technique works on a lot of problems. And then we'll also look at some other techniques. So on this one, well, we already have cosine, but secant is 1 over cosine. Now, if we multiply cosine times 1 over cosine, well, this cosine x is the same as cosine x over 1. We could cross cancel, and this simplifies down to just 1. All right, so let's move on. So secant squared x minus 1. All right, so sometimes when you see a trig expression squared, all right, so trig expression squared with a plus or minus, look for one of the Pythagorean identities, one of those 9 versions that we wrote. So let's see if there's a secant squared x minus 1 that we had. All right, so if we look back, so secant squared x minus 1. All right, so here it is right here. Secant squared x minus 1 is the same as tangent squared. All right, so that's what that is, just tangent squared. All right, so let's keep going. All right, so number 4, tangent x over secant x. Now, there's not just one way to do some of these problems. There's multiple ways, so whatever way that you can use to get it to the correct answer, to simplify it, then it's okay. All right, so tangent, I'm going to change to sine over cosine. And then secant is 1 over cosine. All right, so now I have a fraction dividing by another fraction. I can write this horizontally instead. And so this is going to look like this, sine x over cosine x divided by 1 over cosine. And then division of fractions, we would change to multiplication. And flip the right side. Oops, it's going to be cosine over 1. And then I could cross cancel. And then multiply cross, I get sine x. All right, number 5, secant is 1 over cosine, and cotangent is cosine over sine. And then if I cross cancel, okay, I get 1 over sine, and 1 over sine is cosecant. Okay, so that's what it's going to turn into, just cosecant. All right, 6, tangent is sine over cosine. Cosecant is 1 over sine. Again, I could cross cancel. I get 1 over cosine, and 1 over cosine is secant. All right. Number 7, 1 minus cosine squared. So we have a trig function squared with a minus sign. So look back at your Pythagorean identities, all right, and that should equal sine squared x. All right, number 8, cosecant squared x times cosine squared x. All right, cosecant squared x is the same as 1 over sine squared x. Cosine squared is already cosine squared, right? So leave it as cosine. We multiply across, we can get cosine squared x over sine squared x, and that's going to equal cotangent squared x. All right, and then number 9. Kind of like we did number 4, secant is 1 over cosine, and cosecant is 1 over sine. All right, and then we could change this to a division problem. So 1 over cosine divided by 1 over sine, then change it to a multiplication problem and do the reciprocal. Then multiply across, because nothing's going to cross cancel, so you get sine x over cosine x, and that's going to be tangent x. All right, so if you need to look back at these again, just so you can see the process, changing things to sines and cosines, look for things that are squared with a plus or minus. That's going to use one of the Pythagorean identities. All right, so hopefully this helped, and you can do the homework now.